Welcome to SanfordFlipMath. This is PreCalculus, and we are actually in our second installment on the parabola stuff. We're calling this 8.1, referring to the section of the book from our Demana Foley Kennedy book, but we're actually doing most of our work from the Glencoe Algebra 2 book, probably 2008 copyright. And we are revisiting parabolas because there's a bunch of information that we didn't know about. And that has to do with all of the stuff dealing with Focus and Directrix. And I need to mention Lattice Rectum today just so you have an idea of what that's about. This is a reminder, this is all the little formula stuff. And again, let me remind you that I gave you kind of a little sub-formula here, just F equals 1 over 4A. And that represents the distance from the vertex to the focus. Okay, so everything else is pretty much like what we've known before. Just remember that the focus has to be inside the curve, so inside the parabola and eventually inside the ellipse and the hyperbola. The directrix is on the outside, and parabola is the only one with the directrix, and the parabola opens away from the directrix. So, so just a reminder that a parabola is the set of all points in a plane. Okay, so that in a plane just means that it's flat, and we already talked about equidistant means equal distance. Okay, so there's nothing deep there, and the fixed point is called a focus, and the fixed line is a directrix. And you're already aware that we will probably have some kind of a question on a test or a quiz or something where you actually have to draw an illustration of the geometric definition of parabola, and that's what we're looking at. And so I'm going to do that now, and we'll do maybe 3 or 4 points, and on the test or quiz, usually I typically want 1 or 2. So we're going to locate a point. First, I usually pick one right halfway between the focus and the directrix because it has to be the same distance there and the same distance there. I need to mark them, illustrating that I intend for them to be the same distance. And remember that the distances measured from a point to a line have to be perpendicular. This point right here happens to be directly between the focus and directrix, happens to be the vertex. Okay, so if we were going to know something about little f, this would be little f, that distance. Okay, not that I need that on this particular picture. Somewhere in this area around here somewhere, I'm going to try and eyeball a point that's, looks like that I'd be doing the same distance to here and here. Looks a little long maybe going to the line, but I'm not going to get out a ruler and measure it. I'm just eyeballing. Okay, so that is another point that should be on this parabola. Okay, I could come out a little bit farther maybe, and again the goal is that distance and this distance have to be the same. Again, I'm not going to get out a ruler, I'm not going to get out a compass and try and measure stuff. Put those little right angles on there so we know what's going on. Okay, so as I sketch that, and then I need to do something on the other side similar. Now, so far I have 3 points that are illustrating the definition, and I guess I'll just do maybe one here. And so this distance, and I guess I only needed 4. Oh well, it's all right. And this distance, I just need them to match. Okay, so something like that. Okay, now just a quick little heads up here. The parabola itself is this thing. This is the parabola. Okay, now this is not perfect or anything. I'm freehanding here. Okay, the thing called a lattice rectum. Okay, and I know everybody's giggling when I say that. Lattice rectum, which really all that is that's a little too many bumps in the M. Sorry. It's the line that is parallel, or the segment that is parallel to the directrix. Okay, it's parallel to the directrix, and it goes to the curve. Okay, so on that last slide where it talked about the length of that, okay, so this would be the length of the lattice rectum, so that is this length right here. Okay, so I don't see very many people talking about that, so I don't usually worry about it, but just so you know what's going on. All right, so next up, all right, let's do another equation. We're going to do 1, 2, maybe 3 examples depending on time. All right, so other than the example I already did. We're going to put in vertex form. Remember vertex form from ages ago. We needed to do one that had an A that was not just 1. Okay. First of all, let me recommend that we rearrange this because this is a form. I don't know how that'll come out on a recording, but you know how it is. So here we go. And I need to move the constant. The first thing I want to do is get the constant out of the way. And again, I'm going fast on this because we've already done this back in chapter 2 again, I believe it is. I think it was section 2.1 or 2.2, so you could even go back to those videos if you want to have a little more information. Okay, next up, if there is an A out here, I need to factor it out of everything on the right. Okay, so I'm going to pull this -2 out in front, and this is now going to be x squared minus 4x. Okay, think about why that's minus. Okay, and then remember that to complete the square, it's half a b, so that's going to be -2 squared. So I'm going to add 4 here, and then we can't just add to one side. We have to balance that by adding it to the other side. And there's a whole bunch of, be careful here now, because I didn't really add 4, I really added, so there's a secretive 2, -2 out here multiplying. So I have to add -8 to the other side. Okay, so this now becomes y minus 18 equals -2 times x minus 2 squared. It's always that half of, oop, not quite done, sorry, I got excited and too quick. Jumped the gun. Okay, there we go. That bad boy is done. Okay, so this is vertex form. Okay, so now, vertex. Well, the x value is with x. It's inside, so it's inverse. The y value is on the outside. Okay, in this case. The axis of symmetry. Well, let's just do a little sketcherino here. I'm sure that's Italian for sketch. Okay, I'm lying. So we said the vertex, again, was at 2, 18. So I'm going to go 2 and way up to 18. And it's going to open down, and it's stretched vertically, so it's a little narrower looking than it was. So something like that. Okay. Remember, the axis of symmetry goes right through it, and so this is vertical, so it has to have an x value. Okay, so let me keep my list going here. The axis of symmetry in this case is x equals 2. Okay. So we have vertex form, we have axis of symmetry, we have vertex. Next up, we'll do focus and directrix in just a minute. This is opening down. Okay. Again, it's opening down because of the negative out in front. A is less than 0, and it is opening up or down. So there it is. Let's do domain and range since these are all the older concepts. So the domain for this is all real numbers because it goes far, far to the left and right. And the range, well, the top of this bad boy is wherever the vertex was, so 218. So this is y less than or equal to 18, or if you like the interval notation, something like that. Okay, so we got domain and range done. And next up, we need to do focus and directrix. So that's the other new idea. Okay, so again, the way I handle this is f equals 1 over 4a. Well, 1 over 4a, so 1 over 4 times, well, a is this -2. So this is going to be -1/8, that's the f. And remember, this is the distance from the vertex to the directrix. Well, the vertex, remember, was at 218. The vertex is always inside, I'm sorry, the focus is always inside the curve. So to find the focus, what we have to do in this case, well, if we're going up and down, we're not going to change the x value. And so we're going to do 18, well, it's going to be down, so -1/8, also known as 2, 17, and 7/8. And I'll let you work out how to do that fraction stuff that just happened. Or if you prefer, 2, 17.875. Okay, so that's fine also. Okay, so that's the focus. Now, remember, the directrix is always on the outside of the curve. Okay, and so in this case, we're going to have to go up. Now, this is a horizontal line, so it's got to be y equals something. Well, it's going to be 18 plus 1/8 because I have to move up. So yes, it's going to be 18.125 or 18 1/8. Okay, so that's the directrix. Okay, that is the whole thing, and so we're good there. All right. I want to do an example where I'm going backwards. If time permits, I'll do one that's left or right, but I need to do one where I'm going backwards. So in other words, I give you a focus, I give you a directrix, and now you have to build an equation. Okay, so we're trying to find an equation. Our goal is y equals a times or x equals, oops, sorry, that's not x anymore. Okay, and I'm not sweating whether you can spout off that that form. My issue is, can you make it happen? All right, so my recommendation on this is, ooh, I think I've typoed that. All right, let me give me just 1 second. I think nope, I was wrong about being wrong. Okay, I thought this problem might have said vertex here, but it doesn't. It says focus, and that's going to make the numbers kind of ugly. So just roll with it. It's all good. Okay, I'm going to do a little sketch. Just want to sketch the graph so I can kind of get my bearings as to what's going on. Okay, and slanty y-axis is not so good. So let me try that again. Okay. All right. So, oh yeah, that's so much better. Whatever. Okay. So focus is at -2, 3. Okay, that's the focus. That is not the vertex. The directrix is x equals -2 and 1/12. So that means it's something like this. Okay, so this is the directrix. Now, I think that's a little tight to see what's going on. So I know you're taking notes, but I'm going to adjust this a little bit. Okay, so it's going to look pretty much like it did. Just bear with me. I want to be able to see what's going on. Okay. So, sorry. Okay, so -2, 3 would be here. And -2 and 1/12 is just going to be 1/12 to the left of that. And so this is my directrix. This is my focus. And so just to kind of have a feel for what's going on here, where's the vertex? And remember from our little sketch when we began, it's halfway between. Now, I'm not going to draw a million things. What I want you to see is the focus has to be on the inside. So the vertex has got to be in between them. This is really tight. And then it's going to look something like that. Okay, now, it's probably more like this, you know, a little tighter. Okay, so I'm going to tighten that up just a little bit. Yeah, I'm making a mess out of this. I'm sorry. Okay, and anyway, we'll get there. Okay, and so again, that directrix was right here. Okay, this is the focus, and then the vertex is this point right here. Okay, so first question is, where is the vertex? Well, it's halfway between the focus and the directrix. I know it has the same y value as the focus in this case, because if it's open and to the right, we aren't moving up or down to get from the vertex to the focus. Okay. So the other question is, well, what's the x value? And the x value has to be halfway between this x value and this x value. This is not cute. This is a pain in the, yeah. All right, so this is not fun. So I have to find the value that's halfway between -2 and -1/12. Well, there are a couple of ways to do that. One way to do that is to do a little average. So if I do a little average, it's -2 plus -2 and 1/12, which is -4 and 1/12. Well, to do an average, I'm going to divide this by 2. So this becomes now -2 and 1/24. Well, that is just such a beautiful number, if I do say so myself. So -2 and 1/24. That's the vertex. Yeah, that's ugly. Now, if you prefer, you can write that as -49/24. It doesn't matter to me. All right, so we're almost done with this already, though. Okay, and I know that part wasn't fun. Okay, because it's opening left or right, the equation has to be in the form x equals, and then we have y in the middle here, Okay, so x equals, well, it's going to be y minus the y value, and then we have to plus the x value. Well, since it's a negative, it's plus a minus, so plus a negative, and I'm going to write the 49 over 24. Okay. The only thing that we don't have is a. Well, if you recall, f is 1 over 4a. Well, we can play around with this a little bit. Okay, so, because I'm going to be solving for a, so 4af equals 1. I'm solving for a. So a equals 1 over 4f. Now, you can either remember that or solve for it every time. You might even, dare I say it, pop back and make a quick little note to self that a equals 1 over 4f. So if you want to add that to your little list, you may. F is still the distance from the vertex to the focus. Okay. All right, so with that in mind, how far did we go from the vertex to the focus? Well, here's the focus, and here's the vertex. It looks to me like we went negative 1 over 24. We went left. I think I'm wrong. We went right from the we went left from the focus to the vertex. We went going from the vertex to the focus, we went right 1 over 24. All right, caught myself before I got myself in trouble. So a equals 1 over 4 times 1 over 24. Well, isn't that pretty? Well, from our last work with all of those fractions with the trig stuff, this really isn't that big a deal. So that's really 1 times 6 over 1, so a is 6. So a is 6. Now, just a quick little double check here. This parabola has to open to the right because it has to have the focus on the inside, and it has to open away from the directrix. Okay, it's opening to the right, which means it's opening toward positive numbers, and a should be positive, and it is. It's opening to the right, so it's not y equals, it's x equals, and here it is. Okay, so and we're done. That's it with that. Okay, I think what I'd like to do, and time-wise, I think I'm really good, and this is probably the perfect place to stop. But of course, I'm not going to. I'm going to fly through one more example, and that example is going to be the another one that's opening left or right. Okay, so here we go. This is going to be our last example. And again, what I'm looking for is vertex form, domain, range, axis of symmetry, vertex, focus, and directrix. And there might have been something else in that list, and I'm not going to sweat it. All right, so first up, if there is a constant out here on the end, then move it to the other side. There isn't. Sweet. Okay, next up, we need to, I'm going to move this over here a little bit. If there is a number out here multiplied, I need to factor it out. So this is going to be y squared minus 6y. Okay, and remember we're completing the square, so I'm going to leave myself some room. Half of negative 6, so b over 2 squared. Half of negative 6 is negative 3 squared is 9. Now I just added 9 on the inside, but remember that's not what was really added. So I need to add a negative 18 on the other side. So this is now x minus 18 equals negative 2, y minus 3 squared. So moving that negative 18 to the other side, well, adding 18 to both sides. Y minus 3 squared plus 18. Okay, so vertex form, that's it. Okay, now remember, this parabola either opens up, down, left, or right. Since it's x equals, it's got to be either left or right. Because it's negative, it has to open toward negative. So this bad boy is going to open to the left. Okay, did vertex form. Let's do a little sketch of the graph. Okay, and we'll be a little neater on this at some point. Now the vertex is, okay, so the vertex, remember, is the x value on the outside, so do what it says. And the y value is with y, inside inverse, and we're good there. Okay, so 18 and 3, so somewhere way down here, up 3, something like that. It's going to open to the left, so somewhere like this. Okay, and so domain, well, it's to the left of 18, so you could say from negative infinity to 18 if you prefer, or if you want to say x less than or equal to 18, I'm good with that. The range will be all real numbers because it goes all the way up and all the way down. Axis of symmetry has to do with this y value here. So there's a line through here, and it's y equals 3. Okay, so what's left? The focus, in this case, will have the same y value. Okay, so I already know that's going to be 3. And the directrix, since it's got to be vertical, will be x equals. And I just need to find the value of those two x values. Okay, okay, so just a quick reminder. The distance from the focus to the from the vertex to the focus, little f, again, the distance from the vertex to the focus is 1 over 4a. So 1 over 4 times negative 2, so that is negative 1/8. Okay, and yes, their fractions happen. It's going to happen here. Okay, so that means if I start out at this vertex, which is 18.3, and I move to the left, I'm going to be doing 18 minus 1/8, and then the y value will be 3. Okay, so 18 minus 1/8 is 17 and 7/8. Now, you can make that as an improper fraction if you prefer. 8 times 17 plus 7, I don't know what that is off the top of my head, so I'm just going to leave it like this. Okay, that's 17 and 7/8 that's there. Okay, and now for the other one, for the directrix, I actually have to move to the right 1/8. So I'm going to be doing 18. So the directrix, that's what I'm doing here, x equals 18 plus 1/8. So 18 and 1/8. Again, you can do 8 times 18 plus 1 if you prefer, but I'm good. Okay? All right, not bad. That was the speediest example ever. Well, thank you so much for watching Sanford Flip Math, and we will play more with this in class. Thanks for having me. Bye.